right. I think we've got our SolidWorks issue sorted out. I think so. I had to reactivate the license, so it can now have access to all these nice things. Just so we can start, in case some of you don't watch this until later or don't watch these two videos together, let's actually, hopefully this doesn't mess it up. Let's start our part over. Let's do File, New Part. So what our goal was, we were going to do topology optimization in SolidWorks. And we were going to just use a bracket, like a shelf bracket, of random dimensions. We'll make them into something here in a second, but nothing particularly specific about this. In fact, these aren't even the same dimensions I used last time, but we'll make it work. So this is the side view of our bracket, and we're going to put some holes in it to, mount it onto something like that. Let's make these holes, they're going to be big, 1/2 inch holes. All right, so that looks, it's not all perfectly, because we didn't, I want it to be kind of, evenly spaced and everything. It doesn't really matter for what we're doing. But we'll call this good. That'll be fine. All right. So like I was saying, if you watch the previous version of this where I couldn't get the license to run, then you could make this plate on a water jet or even a laser or something like that. Got this thing. Let's give it a plain carbon steel material. So it's just steel material. And so you could make this and it'd be, a cheap, fast part to make, but there could be a lot of extra material here that you don't actually need. And so you could intuitively go in and figure out, well, this part down here I don't really need maybe, and this part could probably be thinner depending on how much load this thing is having to carry. And so what topology optimization does is you start with kind of this almost bounding box area that represents the part you want to optimize. And so that's this guy. I don't want any material outside of this area, but I don't think I need quite as much material as I have inside this area. And so then we can go to our simulation. Hopefully this works. Yes, here we go. Topology study, so we can do that. And you have the option of topology or design study. We'll do topology. And it will send us over to what looks like our regular static analysis tree over here with the addition of manufacturing controls and goals and constraints. I don't think those are in the traditional static study. But let's, we already have a plain carbon steel, so we got our material. Let's not use connections, let's use fixtures. I'm going to fix these 2 bolt holes. Okay, so that's like a bolt is in these holes holding it in place. Let's put an external force on top of this bracket. Let's say that everything else is in English units, so let's use English. I don't know. This is a 1/2 inch plate, so it can be quite a bit of bolt, quite a bit of force. They're 1/2 inch bolts also. So let's put 2,500 pounds on there and see what that does for us. Okay, so this is exactly like a static finite element analysis so far. Now we've got goals and constraints. So there's the 3 options available are best stiffness to weight ratio, minimize maximum displacement, so it doesn't want to deflect much, or minimize mass. Typically what you do first, even if you want one of these others first, you usually do stiffness to weight ratio first. It's even the default one. So we're going to click on that. And then we've got a couple of things here that we can, how much reduce mass are we aiming for? 30%. In this case, I think there's a whole lot more mass than we actually need. currently it's a kilogram, and that would bring it down to 3/4 of a kilogram. Let's try to reduce this. Maybe let's be really aggressive. Let's do 65%. It may be that it can't do that. You can't remove that much mass from it, but let's just see if we can. There's a couple of other things here. Maybe we want to always have a particular factor of safety or whatever, but we'll leave just this as our target. Okay. There are some manufacturing controls that we might want to deal. So preserved region. So we want to preserve this hole, and this mounting surface on top. And maybe there's some other regions that you have to have because they interface with other parts. So this topology optimization never adds material outside of this box. It's only going to remove from within this box, but it's possible that it would remove our holes, or at least reshape them, or remove this top surface. So, and we wouldn't want that. If that's the mounting surface and the holes where the bolts are going to hold this thing onto whatever it's mounted to, then I want those to remain. And then there's this option, preserved area depth, where I can go in and say around, let's put it all in inches. I want these holes to have 1/10 of an inch of material around them. I have to have that, or a 1/2 inch, or whatever. You pick a number. It'll give you a little preview that kind of shows these purple areas here will not be touched by the algorithms to reduce mass. So you'll always have that available. Let's actually bump it up to 0.2. Okay, now let's say that looks good. And so a little bit of this is a guess, and a little bit of it is you could actually go in and do some calculations to know how much material you need around here to carry any kind of bearing stress in the bolt or whatever. All right. There are other manufacturing controls. If it's a molded thing, it's cast somehow, then you could specify which direction the molds are going to come apart. Maybe there's a thickness control. You have to never get below a certain thickness in a certain region. Symmetry, we might as well do that. It is a half symmetric model. So our plane, let's see if I might have had to have put a plane in there because it's not actually on the actual plane. Let's see if we can, let's see, I'm trying to see. Yeah, did it automatically pick up that? No, it did that plane. So that would actually make it 1 inch thick. So let's remove that one. Delete. I could have built, let's see if I can do it now without losing my stuff. Let's do a plane reference to the front plane and parallel, well, offset. We'll offset it 1/4 inch. And which way did it offset? Why is that? Did I not make this? Maybe I made it way thicker than I thought. That's kind of weird. I thought I made it a 1/2 inch thick, but it's offsetting it kind of not in the middle. Oh, it just wasn't updated. Okay, there we go. All right, now we have a plane right in the middle. Let's go back to our manufacturing, specify symmetry planes, and we can pick that plane. And now it's got symmetry, and it'll only simulate half of the model. You can do half models, quarter models, even little sectors of something that has radial symmetry. And so on a complicated model, this is not a complicated model, but on a complicated analysis, any kind of symmetry you can find reduces your computation time. Now this isn't really going to make any difference, but what's wrong? Oh, yeah, we updated the thing without, it needs a new mesh basically. So let's mesh and run. So I don't know how long this is going to take for it to create our simulation, or in how many iterations. I didn't even specify how many iterations it was going to do. It tries to do a convergence type thing, which it should pop up in a minute, some convergence plots, hopefully. Let's see. Well, it blinked out the screen for a second. I wonder if it's popping up windows in the background that I can't see. I don't think it is. I think it's still iterating. Or getting ready to iterate. I don't think it's even started yet. But at least we can see the process. But I wanted you to see the actual model that gets created from this. But it is a lengthy process for iterating and chopping away at the model, at the finite element mesh that it creates. So it basically runs a simulation, removes some material, runs a simulation, removes some material, runs a simulation, trying to get to that goal. Now, now I'm thinking about it, I probably should have made a much less aggressive goal. Remember, we did 65% weight reduction, and that might make it iterate for a while. We'll see. If it gets on and on and on, we might have to cancel. I don't even know how to cancel it, really. There's no button yet at all. You can see, I don't know, can y'all, no, it's off your screen. Let's see. I can't move the window either. Down at the very bottom, down here, right underneath that, it says what it's doing, and it's pre-running the static study. So basically just the finite element analysis like it normally would. But it is taking quite a while. I'm going to see if I can close some windows in the background to give it a little bit more. But it is having to stream also, and so I might have to fast forward this part. I can't do it live, obviously, but once it's done, then I can go back and make this part faster. Looks like I've still got Prusa slicer running. We can close that down a little bit too. I'd like for it to at least give me the option to show the convergence of where it's at in the model, in the simulation. But it hasn't given me that option yet. Hey, it did a new thing. So it got the model. Here we go. So we can, let's see, I can't review the convergence data yet. I'm not even sure why the iterations are taking quite so long as they are. Like, I don't even, normally once it's done a couple of these iterations, I would be able to stop and save the results or view the convergence data, which I can't do yet. So I may have to, end the stream, let it do its thing, and then come back once it's got something to actually show you, because otherwise it might take quite a while. So we'll see how it progresses here. If it gets to a point, then it starts going. But right now, it looks like it's being pretty slow. And this is a relatively simple model too. It's, there's not a whole lot of complications to this thing. If you're curious in the model of why I couldn't do the topology study to begin with, the topology study is part of the premium simulation, and for whatever reason, I had, when it opened up SolidWorks this time, or this last time, it had only loaded as the academic version. So I went into the license manager. You can go into your window. I probably can't right now, but up here at the window, no, it's in help license manager. And if you're one of our students, you can specifically go check out a license that you want for an amount of time. And that way you don't have to be online or anything to grab the license online. You can even check out the SolidWorks license, but it has individual license for different features. And so I had to go manually check out a premium simulation license, and then now it'll work until I return the license. They automatically return after however long you check them out. Yeah, I'm thinking I'll have to close the stream and come back at some point, because maybe I'll keep the recording going so that I can fast forward through it. But we haven't even got to 1% yet, and we're 3 minutes in, so it might take a while for it to do the simulation part. So I think what I'll do is, at least we got to the next step. We were able to do the beginning, set up the simulation, but now it's going to take a while to actually run the simulation. And then I'll come back and show you the results of it. All right. I will see y'all at some point in the future. I don't even know if it'll be a convenient time today. I don't know when this will finish. It might be 20 minutes. It might be a couple of hours. So whenever it does finish, I'll do the as soon as I can, I'll do the follow up on what kind of geometry it actually produces from this. But right now, it's going to take a while apparently. So we'll see you in a undetermined amount of time.